Hello. So today we're going to continue with exponential functions, and we're going to start solving exponential equations, specifically ones where we can find common bases. And we're going to talk about what that means. So when we solve exponential equations in this manner, there are three steps that we need to be aware of. Our first step is going to be to use the properties of exponents to simplify each side of the equation. Our second step is going to be to rewrite the equations so that both sides have the same base. And we'll talk about what all this means here in a minute. Step 3 is going to be to drop the bases and set the exponents equal to each other. These are your 3 steps that you need to know in order to be able to solve exponential equations. So we're going to go through 4 examples today, and we're going to look at what this means. So for your first example, we have 5 to the 4n plus 5 power equals 5 to the n minus 7 power. Now, the first thing we're going to do is we're going to take a look at the bases that we have here. Our bases in this equation are 5 and 5. They're what the exponents are attached to here. And we notice that they're both the same. They're already exactly the same. So since both of these are already the same, we're going to go ahead and jump to the third step here, where we're just going to take our exponents, what these are, and we're going to set them equal to each other. 4n plus 5 equals n minus 7. And now that we've done that, we can just solve this equation like we would a basic algebra 1 problem. So I'm going to get all of my variables on one side. I'm going to subtract n on both sides. I get 3n plus 5 equals negative 7. I'm going to subtract 5 on both sides. I get 3n equals negative 12. I'm going to divide by 3. And for my final answer, I end up with n equals negative 4. This is my final answer in my exponential equation. Now, to check my answer, I can take this and I can plug it back into n, and these equations should balance out just like they would with any other equation. All right, let's look at a few that are a little bit more complex here. So for example 2, we have 4 to the y plus 2 power equals 16 to the y minus 3 power. Now, the first thing we're going to do is look at these bases that we have here. And these are different from our last equation that we have in that they're not the same. They're both not the same number. So the very first thing we need to do is try to get them to match. Now, 16 is the bigger number, so I'm going to see if I can rewrite this in some way to match it to 4. Well, I can rewrite this as 4y plus 2 equals 4 to the second power, because 4 squared is 16. I'm just rewriting it. I haven't changed anything. Y minus 3. Now, I've rewritten this equation so that my bases now match. Now that I've done this, I can carry on to step 3, where I take my exponents and I set them equal to each other. So I'm going to rewrite this as y plus 2 equals 2 times y minus 3 now. And then again, I'm just going to solve this like a basic algebra 1 problem. So I'm going to draw my line down the middle. Y plus 2 equals 2y minus 6. I'm going to now put all of my variable terms on one side. I think I'm going to subtract y in this case. There's no real perfect way to do it. I'm going to get 2 equals 2 minus 1 is 1y minus 6. I'm going to add 6 to both sides. And my final answer is y equals 8. And there you have it. And again, I should be able to plug this 8 back into y, and these two expressions should end up equal to each other when I finish. All right, halfway finished. Moving on to our third example now. We have 81 to the 2x plus 5 power equals 1/3 to the 2x power. So there's several things going on here. One, we notice right off the bat that our bases do not match. I'm going to deal with this one first, and I'll explain why. I'm going to deal with this one first because this is actually really easy to do. This is something that we would have learned in Algebra 1 that you probably don't remember, but we can rewrite this as the 1/3. We can rewrite this as 3 to the -1 power 2x. So I'm going to rewrite this as 3 to the -1 power because what this allows me to do is simplify this base and get rid of this fraction so that I have this simplified exponent that I can now deal with. All right, now that I've done that, I need to look at this 81. Now, I want to try to reduce this 81 to some number 3 to some power. So I'm going to ask myself, 3 to what power gives me 81? Well, 3 to the 4th power gives me 81. So I have 3 to the 4th power times 2x plus 5 equals 3 to the -1st power times 2x. So I've reduced my bases to where they now match. I can set these equal to each other. So this becomes 4, 2x plus 5 equals -1 times 2x. All right. I can now distribute. So 4 times 2 gives me 8x plus 4 times 5 is 20 equals -1 times -2. That should not be -2x. I apologize. I don't know why I made that mistake. -1 times 2x should be -2x. There we go. We're back on the right track. All right. I'm going to move this 8x over just because all my constants are already on this side. So I'm going to subtract 8x on both sides. I end up with 20 equals, well, -2x minus 8x is -10x. I'm going to divide by -10 on both sides. And I end up with x equals -2 as my final answer. All right, so that one was a bit more complicated, but I think we did all right here. We're going to look at one more example. That's probably the most complex that I'm going to give you. We have 4 to the 2x power times 1/16 equals 4 to the 6x plus 18th power. Now this is different from the problems that you've seen previously because we've just had one term on each side of the equal sign. Here we have multiple terms. We have 2 terms here that we're going to have to deal with. So the first thing I'm going to do is deal with this 16. I can deal with this 1/16 pretty easily. I can rewrite this again as 2x times 16 to the -1 power equals 4 times 6x plus 18. Now, I want these common bases. So I'm going to rewrite this 16 as 4 2x times 4 to the -2 because 4 squared gives me 16. 4 -2 equals 4 6x plus 18. All right, now we've managed to reduce this. We've managed to simplify to all of these common bases. You might be asking yourself, what am I going to do with these two bases or these two exponents here? How am I going to handle these? Well, very basic rule of exponents is that when you multiply like terms, you add their exponents. So we're going to add these exponents, or in this case, subtract, because this is -2. So 2x minus 2 equals 6x plus 18. All right, now we've done that. We've reduced this. This is a very basic Algebra 1 problem. Subtract 2x on both sides. -2 equals 4x plus 18. Subtract 18 on both sides. I'm going to have to move my problem up here. I apologize. I end up with -20 equals 4x. I'm going to divide by 4 on both sides. X equals -5 is our final answer here. All right, those are all 4 examples that I wanted to show you today. I apologize if the quality of this video is not perfect. This is my first time doing it, so hopefully they'll get better as I go. If you have any questions, comments, or concerns, feel free to reach out to me. You guys have been doing an excellent job at that. Continue that, and stay safe.